to my YouTube channel. I am Nathaniel King and your host for this session. I have over 25 years of experience in working with computer software and over 7 years of experience working with cloud and AI. In this session, we will explore Azure Integration core principles. In cloud integration, resiliency and reliability are not optional. They are essential. Let's start with the basics. Reliability means your system consistently does what it is supposed to do. Resiliency means your system keeps doing it even when something fails. Failures will happen. API go down, network connections drop, service limits are hit. A well-designed integration doesn't crash, and when that happens, it bends, recovers, and continues. So, in this session, we are going to talk about resiliency and reliability. Let's look at a real example. Imagine a logic app that sends new employee data from Workday to Dynamics 365 via API management, APIM. One day, Dynamics is under maintenance. The logic app calls the API and gets 503 service unavailable and fails. Our non-resilient design stops right there. Means we're going to throw error exception. The message is lost. The business team has to fix it manually in many cases. But resilient design behaves differently. The logic app detects the failure and retries, which is depicted in the second diagram, the lower one, with exponential backoff. So the logic app detects the failure and retries with exponential backoff. Means it will not try again the same frequency. If it keeps failing, it sends the message to a service bus, dead letter queue, or DLQ for later reprocessing. An Azure function monitors the DLQ, alert the support team, and basically replace the message once Dynamics is back online. We can even add circuit breaker pattern through APIM policies or custom function logic. That stops hammering the Dynamics API with when it's not available and tries again only after a cooldown period. That's the essence of resiliency. The system protects itself and maintains data integrity and keeps operating gracefully. And remember, resiliency isn't just about retries, it's about maintaining trust in your integration when business users know that the messages won't be lost and system can recover automatically. That's the true reliability. All right. So it means they know that it's not going to go. I mean, message will be there. So now the next slide is why do few architects or company not do not think uh, why do a few okay, let me repeat. Why do a few architect or company not think seriously about resilience in integration? And there are various reasons for that. Many architects and companies overlook resilience in integration because they focus on quick delivery. And I have seen this many times in my career. Happy path, they just think about happy path success rather than just long-term stability under the and there's normally they're under tight deadlines, handling failures, retries, or monitoring often feels like extra work. And I have seen companies normally try to do these things at the last, and that's the worst part. Some teams also assume cloud services are always reliable and lack the observability of to notice hidden issues. As a result, resilience is ignored until something breaks in production. But the true enterprise integration must be designed to fail gracefully, recover automatically, and protect business continuity from day one. So, in cloud integration, resilience isn't luxury, it's survival, it's important. When we connect multiple systems, like for example, Salesforce, Workday, Dynamics, and ServiceNow, these are from my previous experience. We are dealing with moving parts owned by different teams, networks, and vendors. That means one truth: failures are inevitable. Means going to happen today or tomorrow. A resilient integration doesn't try to prevent every failure. It's designed to recover automatically. When they occur, they just have some mechanism to deal with it. Let's break down why resilience is so critical. First, to keep business processing. If Workday or Dynamics is down, we can't afford the entire onboarding or billing process to stop. Resilience ensures that the messages are queued, retrieved, and deferred until the target system is available again, and so the business keeps moving even during the outages. Right. So uh, the second point would be to protect data integrity. Could be to maintain customer trust and user experience, to enable self-healing and automation, to build long-term reliability and scalability. There are various reasons it's important to make sure that our systems are resilient. Now, there's another thing we need to think about: how to measure it, because if you do not know how to measure it, then we will not do much about it. So to know whether your integration is truly resilient, you need to have a measurable indicators. The first one is recovery time objective. So it means how quickly system recover after failure, and it tells you how fast your system must recover after a failure. For example, can your logic app workflow resume within 15 minutes? Could be anything. I mean, there's a time. The next one is recovery point objective, RPO. How much data loss is acceptable? So, I mean, how much data company can how much data is affordable by company to lose? If service bus crashes, um, do you lose zero messages or just the last minute of data? So we need to, think about all of these aspects. Mean time to recover, MTTR, average time to fix and restore. So it's a time from detecting a failure to a full restoration time. Is in minutes, hour, 2 hours, whatever it is. You need to have clear cut information on that. Then we have mean time between failure. So how frequently those things happens. So it shows how long for integration runs without breaking. Higher MTPF means higher stability. Average time system runs before failing. And the last one is service agreement. SLA defines the business expectation for uptime and performance. For example, 99.9% availability of your integration endpoint is one a good example. Together, these matrices turn resilience from a vague idea into something you can measure, monitor, and continuously improve. Now, we there are various kind of failures that can happen. So let's just quickly go through. It could be a hardware failure. Any component, any hardware fails, so that falls into that category. Data center failure. Entire data center is impacted by issues such as power grid outage. Regional failure could be disaster, natural disaster, flood, or whatever. Transit failure, requests between various components fail intermittently. and end user request will fail when this isn't handled properly. Dependency service failure. This occur only when the service on which the application is dependent not functioning correctly. Heavy load, a sudden spike because of rush hour, whatever it is, or Black Friday. Accidental data deletion or corruption. Customer mistakenly delete critical data or data has been corrupted due to unforeseen reasons. The last one is application deployment failure, a failure that takes place when updating production application deployment. So now let's see how we deal with these things. So if it's a hardware failure, we can use availability sets. If it's a data center failure, then we can use Azure availability zones. If it's a regional failure, then we can use Azure Site Recovery or multi-regional website, multi-regional deployment. If we have transient failure, we can use retry and various other patterns we can use with it. Dependency service failure, we can degrade gracefully if service fails without failover path, providing an acceptable user experience. Heavy load is can be dealt by using load balancers. Accidental data deletion or corruption. If we have backup data, might be using Azure Backup. If you're using VMs, we can back up this data and we can recover it from there. Then the last one is application deployment failure. Then we need to have an automatic deployment with a rollback plan. Now, there are various features and services available in Azure. We can use some of these already covered. Availability sets, availability zones, Azure Load Balancer, Azure Traffic Manager, Azure Site Recovery, Azure Backup, geo replication for Azure SQL Database, locally redundant storage, zone redundant storage, and geo-redundant storage. So these are the few of them, and we always apply these things for making system more resilient.